In Module 5, Lesson 5, we're going to look at the area of polygons through composition and decomposition. In our opening exercise, we have an aerial view of a woodlot, and they are giving us some information about the different dimensions of this woodlot. They're telling us, first of all, that AB is 10 units, FE is 8 units, AF is 6, DE is 7, and they're asking us to find the lengths of the other two sides. So looking at DC, remember we were told, and let's label, we were told that AB is 10, FE is 8, AF is 6, and DE is 7. It's important to label because once you label, then you will be able to see a little better the dimensions that we're looking at. So DC is going to be whatever is left, because remember this entire measurement, if you were to drag AB down, what you would find is that FE, the 8 units, is part of it, and then the part that is left, if you continue to drag down, is going to be the measurement of DC. Let me draw a line segment to illustrate that. If I take line segment AB, the green line segment, and remember, AB is 10 units long. If I then drag it down to FE, let me make a little mark here, and I mark off right there, which is 8 units. And then I drag down even further. What I find is that what is left is the measurement of CD or DC. So then going back, we find that the measurement of DC would be 10 minus 8, or 2 units. Likewise for BC, we have the measurement of AF, which is 6, and then we also have the measurement of DE, which is 7. And if we add those together, we'll get the complete measurement BC. And then we're asked to suppose that DC is 10 units. Let's go ahead and label them. Remember, this is a new situation. DC is 10 units, FE is 30, AF is 28, and BC is 54. And we're asked to find the lengths of the other two sides. So AB is going to be FE plus DC. AB is FE plus DC, 30 plus 10. And DE will be BC minus AF. Which would be 26. So you can find the measurements, missing measurements in a figure by looking at other sides that may be parallel to and the same length. as those opposite sides. Now, the purpose of this lesson is for us to see how we can take composite figures. And a composite figure is a figure that is made up of a variety of different figures pieced together. And in order to find its area, we would need to figuratively cut these figures up into shapes that we can find the area for, because there's no formula for this composite figure. There is, however, a formula for rectangles. So if I take my pencil and I cut this figure up into rectangles that I can find the area for, then I can add those formulas or those areas together to find the total area of this figure. So one thing I might do then is find the area of this rectangle, which will be 2 times 4. I know that this length is 4 because this opposite length, which is exactly the same length, is also 4. So 2 times 4, which would be 8. And 2 times 4 here, which is also 8. And then I have a rectangle down here. Now, my length, I know, is 7. But my height is not 9. 9 is the full height of this composite figure. I can find how high this section is, however, by taking 9, the whole height, and subtracting the height of those upper rectangles. So 9 minus 4 would mean that it is 5 meters high on the bottom. And then we multiply 7 times 5 to get the area of the interior space, which is 35. Finally, we would add 35 and 8 and 8, which will give us 51 square meters. Now that same figure could be divided a number of different ways. So in the first diagram, we're going to divide the stage into 3 rectangles using 2 horizontal lines, and that's what we did in our example above. 2 horizontal lines, we did 1, 2. On the second diagram, they're asking us to divide the stage into 3 rectangles using 2 vertical lines. So we'd go here and here. And then in the third diagram, they asked us to divide the stage into 3 rectangles using 1 horizontal line and 1 vertical line. So I want to make the suggestion here in this shape. I'm not really sure. Sometimes there are parts of our lessons that make me go, but in this diagram, what I think we should do is add in 1 horizontal line, making this one large rectangle, and then we could find the area of the interior rectangle, the part that's being cut out, and subtract the 2. So what we would be doing then for the area of the larger rectangle is multiplying 9 times 7, which is 63, larger rectangle, and then the dimension of this interior space in between would be 7 minus 2 minus 2, which is 3. So 9 times 7 is 63, and then 3 times 4 is 12. 63 minus 12 would be the area of our shape with this piece cut out. In example 2, we are decomposing polygons into rectangles and triangles. Now you recall that we found the area of parallelograms before, so we know that the formula for area of a parallelogram is base times height, and of course the height has to be drawn perpendicular to the base. They're asking us to draw a diagonal from A to C and find the area of both triangles ABC and ACD, and then draw in the other diagonal from B to D and find the area of both triangles ABD and BCD. So let's start off drawing our diagonal from A to C. And then to find the area of both triangles, we again would have 1/2 times the base times the height. The base being 6 meters and our height being 4. Oops. And our area would be 12 square meters for each triangle. And then if we do the same thing with a different diagonal, let's clear this, put a different diagonal in, B to D, then our formula for triangles ABD and BCD will be exactly the same. So we have 1/2 times our base, which is 6, times our height, which is 4, and that gives us 12 square meters, which times 2 is 24 square meters. So we can see that we can cut this polygon, which is a parallelogram, into 2 triangles and find it that way. Likewise, with a trapezoid, we can cut it into triangles as well. So in asking us how else we can find this area, there is a formula for trapezoids. I'm going to introduce it to you now, simply because we talked about each of those triangles. So the formula involves using the distributive property. We're multiplying 1/2 in each case, and we're also multiplying by 5 our height in each case. So 1/2 is being multiplied times 8 and also times 4. Thinking back to the distributive property, we could do something like this: 1/2 times 8 plus 4. Those are those 2 different numbers that we're multiplying by. And then times the base, which in this case is 5. So I'll substitute 5. One half times 8 plus 4, which we actually call base 1 and base 2 in the formula, and then times the height. Can you still cut it into triangles? Absolutely. And when we do that, that will also give us 30 square meters. So to find areas of shapes that are unusual to you, cut them into pieces like triangles and rectangles that you do recognize. And as long as you have the measurements that will help you get the new measurements of those triangles and rectangles, you can easily use those to solve the problem.